Road to Olympiad.
Welcome to RTO. Consider the following problem. Given that x squared plus y squared minus 2x minus 2y plus 1 is equal to 0, where x and y are real numbers. Find the minimum value of x plus 1 over y. This is a very typical problem on algebra that require us to find the minimum value of certain functions. Pause the video if you like to give this problem a try. And when you are ready, keep watching to learn how to solve it. To solve this problem, first, we notice that from the given equations, we can add 1 on both sides of the equations, and rearranging it a little bit, we will come to these equations, which we can factorize the x squared minus 2x plus 1 as x minus 1 squared, as well as the y squared minus 2y plus 1 into y minus 1 squared. Notice that this gives us an equation which is in the form of the equation of a circle of radius 1. And thus, we can let x minus 1 be equal to sine theta and y minus 1 be equal to cosine theta. From x minus 1 is equal to sine theta, we have x is equal to sine theta plus 1. And similarly, we have y is equal to cosine theta plus 1 for the second equations. Here, the given function x plus 1 over y can be written as sine theta plus 2 over cosine theta plus 1. And we let this one be equal to k. Then, by multiplying both sides by cosine theta plus 1, we get sine theta plus 2 is equal to k cosine theta plus k, which we can rearrange to get sine theta minus k cosine theta is equal to k minus 2. Here, we are going to make use of the trigonometric R method, which we can express the expressions a sine theta plus b cosine theta as r sine theta plus alpha, where r is the square root of a squared plus b squared, and alpha is the inverse tangent of b over a. In this case, we can rewrite the left hand side as square root k squared plus 1 multiplied by sine theta minus alpha, where here alpha is the inverse tangent of k over 1. And this tells us that sine theta minus alpha can be written as k minus 2 over square root k squared plus 1. And notice that this is a sine function, so the value must be at most 1. From the inequality we obtain here, we can further simplify it into k minus 2 is less than or equal to square root of k squared plus 1. Squaring both sides and simplifying the equations, we get k is greater than or equal to 3 over 4. Recall that k is equal to x plus 1 over y, which is our required functions. Thus, we have our required function x plus 1 over y is greater than or equal to 3 over 4, which tells us that the minimum value of x plus 1 over y must be equal to 3 over 4. And this marks the end of our solutions. Post in the comment below if you have any thought on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.